Okay, good afternoon and welcome back to those of you who were here last week to today's second of two erosion and sediment control workshops, which is being hosted by Kawartha Conservation in partnership with City of Kawartha Lakes and the Sustainable Technologies Evaluation Program, also known as STEP. My name is Sarah Finnemore and I will be assisting with today's course on behalf of STEP. And today's course will be instructed by Lisa Rocha from the Toronto and Region Conservation Authority, and she is a longstanding project manager with STEP. So before we get started, I would just like to mention that while audio is available, we ask that you save your questions until the question period or type your question in the chat at any point during the workshop. And I will either read your question out or call on you to turn on your mic during the question period. Today's session is being recorded, and I will now pass it over to Lisa.
Thank you, Sarah. Hi, everyone. Welcome and thank you for joining us for this workshop today. As Sarah mentioned, I'm Lisa Rocha. I'm a project manager with the Sustainable Technologies Evaluation Program at TRCA. Over the course of my time at TRCA, my work has been focused largely on stormwater and erosion sediment control research and guideline development. And most recently, I led the development of the updated Erosion and Sediment Control Guide for Urban Construction, which we released in 2019. Kawartha Conservation reached out to me to organize this workshop as they really are interested in raising the bar on erosion and sediment control in the region and definitely feel that education and training is an important and integral part of that goal. So during today's workshop, I'm going to be focusing today on providing the latest guidance on ESC best practices. And it's going to be drawing largely from information in the 2019 Erosion and Sediment Control Guide, as well as some curriculum from other ESC courses that STEP has offered over the years. I don't want to talk too much about this because I think a lot of people here attended also last week, but the program I'm with at TRCA is the Sustainable Technologies Evaluation Program. It's a conservation authority led. Right now, the members are Lake Simcoe Region Conservation, Credit Valley, and TRCA, and we are really focused on just supporting broader implementation of sustainable water technologies through research, monitoring, and evaluating those technologies. Then we look at strategies to overcome any potential implementation barriers, like whether it be cost or a lack of understanding of how they work. We'll tackle those strategies, those kind of barriers by either doing research or advocacy or training. We also develop tools. We have a treatment train tool for low impact development. We also have like online tools like the Wiki, which is a wiki resource online guide for low impact development, all aspects of low impact development, design, maintenance, everything you can need to know about low impact development. And we also develop guidelines and policies to support broader uptake and things like today. One of the primary things we do is education and training, knowledge transfer. So events like today is one of the primary focuses of the program and mobilizing the knowledge that we have gained through our research. Okay, so today I'm going to be covering these key topics. I'm going to be focusing more on application of erosion sediment controls and specific topics like dewatering protocols and winter preparedness. We'll also be discussing legislation that's relevant and you need to know if you're involved in erosion sediment control or construction, at all really, and designing ESC plans for construction projects. We're also, if you're interested in more detail on the ESC fundamentals, like an overview of the erosion methods and sediment control methods and best practices, I also encourage you to check out the workshop that took place last week. I know Kawartha CA will be posting it online soon, so I can keep you posted on that and send out a notification when it is posted. But there's a full video, so if you need any of that background information and you didn't attend that session, I would encourage you to try that one as well. I will be stopping for questions and maybe a 5-minute break at one point. So feel free to put your questions at any time in the chat, and I can address them when they come up when we get to the discussion period. Okay, so just again, I mentioned the ESC guide in my intro, but I wanted to just focus, just kind of give an overview of what it is. So it's, to me, new, but still really new-ish, because it's 2019, so has been several years since it came out now. But It's a significant update to the 2006 guide that was the Greater Golden Horseshoe Area Conservation Authority's Erosion and Sediment Control Guide at the time. Many conservation authorities, municipalities did adopt those practices. This is a significant update, and some of the main things that I think are new and interesting about this one is the qualitative erosion risk assessment methodology. So it's a way of looking not just at your soil types, but like asking people to look at different things that affect your erosion potential and do a qualitative assessment to understand where those risk areas are and how you can best take advantage of and invest your money in your BMPs, like, and putting them in the right location and reinforcing the highest risk areas. We also tried to clarify the EAC approvals process with flowcharts and checklists. We heard a lot of the time that proponents and consultants putting in applications were sometimes confused by processes, approval process. So we tried to make that a little bit more clear. We updated information on best management practices so that we would no longer use proprietary names like, Filtrex, Siltsox with an X. Everything's generic. So there's no, need to keep updating every time there's a new product on the market. It's just like a general product category that is used to name everything. We also have more guidance for in-water isolation BMPs. We included a sizing calculation for in-water isolation barriers, which is interesting. It's like a very simple calculation based on the amount of risk you're willing to tolerate and how long the cofferdam, for example, is going to be in place. So that's a really interesting one that we included this time around. We also included description of risks to low impact development features like bioretention swales, infiltration, trenches and chambers, all these infiltration based on the ground green technologies that are becoming more and more common can be very clogged and compacted during the construction process if they're not protected. And so we included some pretty detailed guidance on how to protect those. We also include guidance on ESC effectiveness monitoring, turbidity target. For the first time, we always have heard from the industry, like nobody understands what really the goal is, like what should my water quality, what should my turbidity be downstream, like what's the maximum tolerable increase from my site. And there's not a lot of concrete data out there, not concrete data, concrete guidance, policy, rules out there that very clearly states what those should be. And so we included some guidance that we think is makes sense. And if you wanted to look at the guide in more detail and just peruse it yourself and keep it, it's available at sustainabletechnologies.ca/ESC-guide. Okay, so getting right in, we're going to dive into some information on pumping and dewatering best practices for construction projects. I think the important thing is just having dewatering protocols and plans in place will allow you to deal with your planned dewatering and any unforeseen dewatering activities that have to be conducted, so that you can just, always have a plan to mitigate sediment releases during those activities. The ESC plan should definitely include dewatering protocols that direct staff on how to handle active and passive pumping discharges. Some of the common activities where you can anticipate you're going to end up needing pumping or dewatering would be sediment control pond dewatering to clean it out, facilitate any like regrading or maintenance dredging of your sediment control ponds. Like on a multi-year construction project, you should definitely have to clean out your sediment control ponds at some point. It's not gonna be okay to leave the sediment control pond without being cleaned for 4 years or whatever. Pumping out stormwater that accumulates in an excavated or low-lying areas following a large event so that you can continue your work after. Using a sump pump to remove groundwater and excavations that extend below the water table, and repairing or replacing any underground services. So some of those are the most common activities we're going to need to do this work. There's a lot of important considerations really to think about when you're trying to decide on your protocol and make your plan. One of the things you want to think about is your allowable water movement rates that are specified in your permits. So, for example, in a permit to take water or EASR, Environmental Activity and Sector Registry, EASR registration, you could be required when you're taking, those might be required when you're taking more than 50,000 liters of water in a day from a surface or groundwater system. But pumped water is being discharged to a municipal sewer, for example. Discharge permits are also typically required. And while specific permits are going to vary, like you're not going to have the same requirements from municipality to municipality, they do typically include like a maximum allowable discharge rate. Also, you want to consider the receiving water system and the standards of that system. So water that's discharged directly into a municipal sewer, for example, either a storm or sanitary, is usually subject to the municipalities. A lot of them locally would be the sewer use bylaw here in the GTA. And there's the sewer use bylaw specifies specific contaminant limits. Some of them are actually quite strict. So when you're dewatering, you have to abide by those limits. So that's what you have to understand before you're going to be pumping water, whether you're meeting those criteria for the discharge to the sewer. Then if you are actually discharging directly to a natural water feature, my recommendation would be to consult with the turbidity targets that have been provided in Chapter 10 of the Erosion and Sediment Control Guide. Those would be the ones that would be the most applicable and advisable to adhere to. There's also temperature standards to consider for discharge to natural features. When you release water to natural features, they should fall within the appropriate temperature range that's based on the organisms supported by that habitat. So for example, groundwater can actually be significantly cooler than the receiving water system. So you might want to make sure you allow for pardon me, a gradual initial release to allow aquatic organisms to adapt to the temperature differential. Also, where you're discharging much warmer water in a cool water fishery or cold water fishery, you want to ensure that you're not exceeding the threshold, which for the MNRF typically recommends. For example, for cold water endangered species like the red-side dace, which is found in GTHA areas, the upper reaches, you don't want to be exceeding 24 degrees Celsius. Also, you want to look at how close you are to groundwater. If you're doing groundwater dewatering, how close you are to natural surface features. When groundwater is being dewatered near a surface water feature, the water level in the feature could be impacted by that dewatering. And so depending on the zone of influence and the amount of water that's being pumped out, you have to consider those factors. It's important to know the groundwater condition in the area in advance of doing your dewatering plan. So if a natural surface water feature is located within the anticipated zone of influence, the local conservation authority should be consulted to provide advice and help establish strategies that you can use to prevent impacts to the hydrology of that surface water feature. When you're looking at also erodibility at discharge locations, you want to make sure you're preventing erosion at the outlet of a dewatering system, because that's just as important as ensuring you treated the water in the system, because what's the point of treating water in dewatering treatment system if you're just going to mobilize sediment again along the flow path between the discharge point and the receiver? So what you want to do is make sure it's stabilized with stone, geotextile vegetation, rolled erosion control products, or whatever is appropriate for the flow rates and area in question. And you want to consider what those flow rates might be and whether the ground's going to be stable enough to support those flows in that area. And always consider flow dispersion and energy dissipation, especially if you have a concentrated or high flow rates that are coming out there. You want to consider whether you can disperse those flows and make the erosivity less. You also want to consider whether there's any requirements for quality and or quantity monitoring. So for example, permits issued for dewatering activities, permits to take water, conservation authority permits, Ministry of Environment permits or authorizations under the Endangered Species Act, all even sewer discharge permits, they include requirements for periodic or continuous monitoring of the quality and amount of water that's being moved. So you have to consider, do you have to do monitoring of this, and how am I going to monitor this discharge, and what's my monitoring plan going to be for this? And lastly, really important is contingency planning. An effective contingency planning can be implemented like on short notice. So it means that materials are available or a vendor that you need to hire quickly is available and accessible. So like, for example, a really proactive approach would be a potential to have, if you have a potential water quality issue, is to have a plan to get a dewatering tank, like a weir fractionation tank or active treatment system on site and installed quickly if needed. So having that information on hand, having materials on hand to replace when something's wrong, all these are really important part of your contingency plan because it's pretty a lot of times something will go wrong. That's on construction projects, it's pretty common, and just having that contingency in place demonstrates your due diligence and mitigating sediment releases. So some of the most common, like, and this goes from like pretty basic to like pretty complicated and expensive best practices for pumping and dewatering. So just pumping water out and treating the water before it's released and also dispersing it. One of the main things you see a lot of times are sediment bag, geotextile fabric bag. That's the one in the top picture there. It provides energy dissipation and filtration. So what happens is you're kind of like slowing water down by going through the bag and sediment will fall out. There's some filtration effect, but in general, it's actually the fact that you're just slowing the water down. You're also dispersing the flow over like a much larger area, not having like a concentrated pump outlet anymore. So that's really beneficial there. Another option, that's the middle picture. You can incorporate polymer flocculants. They cause particles in the sediment to bind to one another, so they become larger and heavier and more likely to settle out or be filtered out of suspension. So you can incorporate them in something like a ditch configuration, which is pretty popular because it's like passive meaning once you discharge it from your pump hose, it just flows through the ditch into its eventual destination. And so that's one common way to apply polymers if you want to speed up how quickly water is going to be clarified. Another way is just another level of kind of expense this would definitely be, because a lot of times you have to bring in a vendor to do this. A supplier would be dewatering weir fractionation tanks, come in various sizes. They can be pretty easily shoehorned in, like, maybe there's a project where you want some detention, but you didn't build a pond or don't have space for that. These are, commonly used where there's not a big footprint. It provides just an opportunity for settling. The weirs help dissipate the energy, and you can optimize the sizing of the weir tank based on your targets and your particle size distribution of sediment and like what pump rates you need to really achieve on your site. So not manufacturer, but supplier of those products that are going to bring those services to you would help you do all that. And then lastly, that's the bottom picture on the right there is active treatment system. That's more like what they were talking about in the video. And that's when you want to do more intensive water treatment, depending on how many different components you have in a system like that. It's like putting a water treatment facility on your site, really. It's suitable where there's less intensive options are providing insufficient treatment, and you have very specific contaminants of concern and very, strict discharge requirements that you can't otherwise meet. It may be the only option you have in those cases, and so they are used, they exist, they're out there, and there's a lot of projects where they may be needed. So something to consider. It usually includes something like a polymer phase or something like that, like a flocculant type of thing. And then they may have a polishing container. So you would pass through something like a sand filter. I think you can get as many bells and whistles as you want to make the water as clear as possible at the end of the system. But yeah, there's different, as you can see, there's different containers that house different parts of the treatment train, and like as you can see down below, and then you can even check the water at some of these at the end and just kind of see it pouring out and see how clean it is, and test it even. So that's something that's available. Going into a little bit more about sediment dewatering bags. These are composed of geotextile material. They remove sediment suspended from turbid construction site discharges. It's always important to put on a flat, stabilized area. Grass, if you can, but grass that's stable grass, not brand new grass, and stone lined is also a good option. I've seen some examples where it would still have to be a stable surface underneath, but sometimes I'll put like a pallet of some wood pallet just to make it easier to lift off after and just give it ability to like drain below so it's not sitting flat on the ground. At least 30 meters away from the receiving water system. it's always better in a treatment drain approach, sorry, dewatering treatment drain approach. So that's where you would include more like barriers around it, and ideally like a silt sock barrier around it, and just provide like multi-levels of treatment around the bag so that you are getting the maximum amount of treatment. The water would be pumped into the center, into the bag, and then flow out around the bag to all around the perimeter of it to like a silt sock, and then beyond. So you always want to make sure it's securely clamped to the inlet hose and is inspected regularly, replaced when full. So that's really important. Inspecting those is important because if that goes wrong, and it can go wrong, then it's a big problem, and a lot of sediment releases can happen that way. Okay, so this is this dewatering treatment drain I was trying to describe earlier. Bear with me, I'm going to try to look at this a little bit. Yeah, so let's better closer look for me. So this is just to illustrate that you can apply something like this in normal and frozen conditions. So if you want to use in a normal condition, you can use the sediment bag, dewatering bag in the center. You want to overlay the area with filter fabric. So as you can see, there's filter fabric underneath the geotextile bag, but over top of the staked in filter socks. And you can see there that they placed it on a wood pallet skid just to make it easier for water to drain and also for it to be taken away after. And this just provides like, they also secure the geotextile fabric with these sandbags, and just gives you like a multi-level, it's really the multi-barrier approach, but you're just enhancing the treatment as much as you can with measures that are relatively simple to put on site. If you have frozen conditions, you can just pump the water directly into the center of this area instead of having it into a bag, and then just, oops, put a second layer, not layer, but perimeter of silt socks to enhance the amount of treatment and settling you're going to get from the water that's being pumped in there. So that's a winter option, which sometimes there's not a lot of winter options, so you always want to take advantage of the ones you have. Okay, speaking of winter options, we're going to talk a little bit now just about winter preparedness, which I know is a topic that can be really challenging. So when you talk about construction sites during the winter, there's really not a high potential for erosion when it's frozen, but when there's a thaw event and then an intense rainfall, and when you have those unstable ground conditions caused by snowmelt or melting frost, that's when you have the highest potential for erosion. Spring, after when there's a thaw and after a lot of that snow melts, is when you see the highest incidences of sediment releases and spills and things like that from construction projects. So when you have mild winter temperatures and rains, because the ground's not stable, and there's many challenges with installing sediment and erosion controls when you're trying to put them in the winter. So that just exacerbates the problem. And so there needs to be kind of a different approach to solutions. So here kind of just illustrates what happens with the soil. And so the frozen ground is generally erosion resistant, of course, but the soils that have high moisture content are subject to heaving and freezing action, and they're easily eroded upon thawing. So when you alternate the freezing and thawing cycle, it creates pressure which lifts the soil up out of the ground, and then the downward pressure damages the soil by compacting it, while the upward pressure creates that frost heave and damages the soil structure, breaks down soil bonds, and it reduces aeration. It just creates poor drainage condition in the soil. And so that frost heave cycle occurs mostly in early spring, sometimes late fall, and it's when you'll have like cold temperatures and abundant soil moisture are present, and that's when you can see that kind of start to happen, the frost heave. And heaves can happen in any type of soil, but soils that retain a lot of moisture, like silt, loam, clay, they're the most prone to heaving, really. So, I mean, this is the problem here. I mean, we're kind of focusing on the problem, and we're going to start talking about solutions, but your ESC toolbox is diminished in the winter because of the conditions that you're faced with. So when you're talking about implementing something for like during the winter season when ground's frozen, these are some of the challenges. With vegetative ground cover, you can't establish it outside of the growing season, and it's automatically the most effective erosion control is not available. Hydro seeding is challenging because stabilizers are not as effective in cold conditions, and you're going to have poor growth over the winter. When you're talking about diversion structures like cutoff swales, it's not as easy to try to build anything like that when the ground that is frozen. Also, sediment basins are hard to install in frozen ground, and they can also be overwhelmed by spring melt, even if you have one in place already. So you can't just rely solely on that as your only BMP and not expect that it may be overwhelmed by the spring melt flows that you're going to experience. Sill fenced, again, because it's trenched in, it's hard to install and can't install really in frozen ground. And it can often fail during spring melt if it's not reinforced well or not bolstered well and not maybe had multiple barriers in place. With erosion blankets, you can't really install it that well on frozen ground, and improper installations that are not keyed in will slip away in those melt flows. With grassline swales, again, installation on like a frozen ground is difficult. And then even for paving, I think paving can be possible in cold conditions, but it's not as easy, it's challenging. So a lot of these things are not as readily available, like some of the tools that you would use to stabilize your site and prevent sediment mobilization. And so if you think about it, like how do you prepare for winter? And like, I think in the case of the fact that there is less in your toolbox, what it means is you can't respond in the moment as much and just address things there. You have to be way more proactive and think before winter and make plans before winter. So you have to, before, anything, you have to do a pre-winter inspection and assess, the current site conditions and ESC practices. And you have to determine if any maintenance is required and what you're going to have to put in place to bolster existing ones so you're going to be ready for any kind of melt events and all that. So you want to ensure your basins and traps have adequate storage capacity. You don't want to go in to the winter season having a sediment basin that's full of sediment. They should all be cleaned out. Long-term stabilization should be established anywhere you can, so on exposed slopes or stockpiles, and by methods that are appropriate for that slope steepness and length. Examples like soil cover, tracking, rolled erosion control products, or even sod. You want to inspect the erosion controls to ensure they're securely installed and in good working order. You don't want to have them just not functioning at that point in time. You want to remove storm inlet sediment controls at locations that can cause safety concerns. So you may have like ponded water and ice. You want to replace those prior to snow and increase inspection to ensure those flows are not being impeded there from that control. You want to stabilize the bottoms and the side slopes of ditches and diversion channels, and just look over your site, anticipate areas of potential runoff, like where are you going to have a lot of runoff and flows from spring melt or any major in the middle of the winter melts, and determine if you need more ESCs and if you need multiple barriers in place. So when you want to go back and start stocking your toolbox again and rethinking about, okay, like I can't do that, but what can I do? That's the key thing. You want to start by preparing detailed site winterization plans. So you want to look at what strategies will work for you, and you prepare a site winterization plan that's going to be implemented during winter construction works. And in the plan, you want to give special consideration to how each control or practice will be maintained. So that's going to happen throughout the winter. It's not just like you go and leave it if you're not doing active construction. And remembering your best defense is always multiple lines of defense, or also also known as a multi-barrier approach, where you have multiple controls in sequence, and if one fails, there's always a backup. So you have that redundancy in place. So when you consider stocking your ESC toolbox, all ESC measures that can be installed should be installed. And so sill fences and other practices requiring earth disturbance must be installed prior to frozen ground. There you want to maintain adequate buffer width from perimeter controls and large access points. Have a snow management plan that shows snow pile locations downstream of exposed soil areas and notes that ESC measures should be cleared in prep for your inspections and maintenance. And drainage structures should be kept free of snow and ice dams. So a lot of things to consider when you're just restocking. Then when you consider, there's a few more options. So you want to also limit the exposed area to those that can be in which work's going to occur within 15 days and that can be mulched in 1 day prior to any snow event. So mulch applied and consider that mulch applied for stabilization should be applied at double the standard rate when you're talking about applying it in the winter. If a delay is anticipated in finishing slopes, then all the exposed areas should be covered in mulch, like a rolled erosion control product, like a blanket, and then combinations of these depending on slope length and gradient. You could also break up the slope by using like flow interrupter, like sill tocks, sill fence, choir logs along the slope to interrupt the flow and take away some of that erosivity, and also consider slope drains. Again, multiple lines of defense are always the best way to go in this case. If the slopes are finished, then you can cover them with an erosion control blanket that can be seeded through the spring, assuming that you cannot establish permanent stabilization at that time. But the best ESC measure known and available is final stabilization or permanent stabilization. You also want to consider choosing more effective winter-specific erosion controls, but not like the typical measures that we always see talked about. So for example, you might want to do something like a mulch berm at perimeter rather than a silt fence, because the berm can be constructed on top of frozen ground without compromising its effectiveness, whereas you can install the silt fence in frozen ground. Or if you do a winter installation of silt fence, it's not as resilient as trenched-in silt fence. So you want to also ensure all exposed subgrades get graveled or tracked to create like a rough surface that helps slow all your flow velocities. And lastly, you just want to make sure you regularly schedule winter ESC inspections. Regularly schedule them, and not like necessarily less than you would in the other season if you are continuing work during the winter. This is just a little example. It says from Maine, and it's a winterization plan. So this is something that would be included in your ESC plan, all these kinds of notes. The dates are going to vary from place to place based on like the growing seasons and all that, but it's very specific and detailed, and it's specifically just focused on stabilization before winter and provides dates, very specifically directing people working on the site as to when they should be achieving these specific stabilization milestones. And so I think something like this would be really important as part of your winterization plan to include with your ESC plan. Okay, so we're going to move on to inspections and monitoring. I feel like we've had quite a bit of time, so I'm just going to ask now, Sarah, if you have any questions that have come up in the chat. I think I would probably see them, but if anybody has any questions, they also can, just say them out loud. I will have another like spot for questions soon, but I just wanted to give a chance now after we've covered all that content.
I have no questions in the chat yet. If anyone has any questions, just put them in the chat or raise your hand. We can get to them at any point. So I think for now we can keep going.
Sounds good. Okay, so the next few slides we're going to consider the best practices for inspections and monitoring. So you can have a great ESC plan, but unless you inspect your site and do some sort of monitoring of the effectiveness of erosion sediment controls, and of course, after you've done that work of identifying those things, maintain your controls based on the outcomes of what your inspection and monitoring has discovered, the ESC plan can be the best thing in the world, but it won't matter because you're not following up as to what's really happening day in and day out on your site. So it's crucial to having a site that is effective. The inspection is just like your walkthrough of the site, carried out by ideally a qualified person qualified to do inspections, and we'll talk about what that is. For monitoring, you want to just on an ongoing or periodic basis assess like the quality of your site discharge, and other monitoring parameters. Depending on your site, you may have to look at temperature, you may have to look at certain contaminants, just TSS, you may have to look at flows, but you want to consider doing some sort of monitoring may be pretty basic or very involved if it's required of you, but monitoring is important because it's really the point where you see, okay, erosion sediment control doesn't look like it's working. The sill fence is down. It's not looking good. You don't really know like what that translates into at your site discharge points in terms of an impact, an impairment of that water quality, unless you do some sort of monitoring. So something to consider. And maintenance is just mostly a lot of sediment removal, repairing, ESCs, adding, upgrading, replacing as needed to make sure that it continues to be the level of protection you designed. For ESC inspections, the goal is to regularly assess the effectiveness of individual ESCs and your overall ESC plan. You want to also, in your inspection, identify the need for maintenance. So example, sediment removal and repairs. You want to identify areas where ESCs should be replaced or augmented due to the fact that you see repeated failures. I think also like one thing you'll see on inspection reports, and one thing I've seen that's been really good in the past is, just how many weeks this has not been functioning properly. So like, it's been 3 weeks, this still hasn't been fixed. Identifying that you've said this before, this is the third week I'm identifying this problem. That's something important to track. Pictures, locations of where these impaired areas are all important to include in your inspection report. And beyond the condition and functionality of the controls, you want to, in an effective inspection, you want to do ongoing assessment of the adjacent natural features, and you want to actually look and see like if you're having an impact in what the feature looks like, and kind of track over time whether it looks like you're having some sort of negative impact on the feature. And so not just stopping at your site perimeter, but where your discharge points are into other private properties or receiving natural spaces. You want to look at those areas too and track that and as part of your inspection. So and inspections only half the story. So the effectiveness of a construction site inspection is dependent on the frequency and immediacy and robustness of the actions that are going to be taken to address those deficiencies. So you can do inspections every single day and just identify everything perfectly. And if something's not done like quickly to address that, and like really take that seriously on the site personnel, the contractors are not taking that seriously and mobilizing efforts to fix those things, because they just see it as a formality, just inspecting for the sake of inspecting, then it's meaningless to have an inspection. It's important that it be carried out by a qualified ESC inspector, someone like CISIC, so Certified Inspector of Sediment and Erosion Control, another designation in the Canadian Standards Association Inspection and Maintenance Guide, Inspection and Monitoring Guide. Sorry, I don't remember the name exactly of that standard, but it came out around 2019 as well. They identify skills and knowledge and education for somebody that would be considered a qualified erosion and sediment control inspector, QESCI. And it's not dissimilar to CISIC. It might be slightly more onerous, and there's also QESCI-IT in training that they acknowledge as well. And just remember, the ESC plan should evolve as necessary to ensure that the features are protected. So the efficacy of the inspection program is contingent on like applying the information collected during inspections, adapting the ESC plan to site conditions, and making the repairs and maintenance, doing the maintenance that's identified as being needed in those inspections. So how often should you inspect the site? You want to do a pre-construction inspection to verify the erosion sediment controls are installed based on the approved plan. And then once construction begins, The inspection should occur on a weekly basis during active construction. You want to do it before and after significant rainfall events. You want to do it after significant snowmelt events, after any extreme weather, like, for example, like a windstorm that could have damaged some of your controls, like particularly silt fence. You want to do it daily during an extended rainy or snowmelt period, and monthly if the site's inactive. So if it's greater than 30 days, you just go on a monthly basis if none of those other conditions are present. If there's a spill event, you want to go during or immediately following that. Occasionally during an event, if it becomes necessary to see how water is moving through your site, that's a very smart thing to do if you have the capacity and the budget to do that, just to visit the site during an event just to see how water is moving and not just the aftermath where you see something's been damaged, but I don't know how this happened and where the water flowed to get here and how it all happened. So during an event, if it's safe to do so and within budget and possible. You want to inspect before winter shutdown to ensure the site is ready for freezing conditions and thaws. And at the end of construction to confirm that you've achieved at least 80% effective stabilization on your site. So for ESC performance monitoring, this is the monitoring of site discharges and or downstream water quality, which can help you understand whether the controls are working to actually mitigate environmental impacts. Turbidity is a parameter that's often measured on construction sites to assess ESC effectiveness, and it's used to serve as a proxy for total suspended solids. So turbidity is an optical property. It's the cloudiness of the water. So it's not exactly like just sediment. It can be cloudy for other reasons. But in practice, the water turbidity is often measured and used as a proxy for TSS, which is the total amount of actual suspended solids. Since the turbidity can be measured on site in real time with something handheld or like a station that's permanently in place in like something like a YSI meter. And for this reason, because duration of exposure to elevated turbidity is also an important factor when you consider like whether that's going to have a negative impact on ecosystems. You want to be able to address and get a number right on site. And so the receiving water and effluent targets that we put in the erosion and sediment control guide are turbidity targets for that reason, because you can't measure TSS on site, and so you can't get that kind of as easily duration of exposure and on-site real-time kind of information through that process. You have to send it to a lab. And you're going to have your monitoring approaches are definitely going to vary based on your site details, where you can monitor, what the project needs are based on what you're actually doing, what kind of contaminants could be present, what are your regulatory requirements, sensitive areas nearby. There's so many things to consider. So here are some of the site-specific considerations. You want to look at erosion risk and where you have like high potential for erosion. You want to do more intensive monitoring for high-risk erosion sites. When you look at your receiving water system, for example, are you going to a natural feature or the sewer system? And what are the thresholds that you're required to meet in either of those instances? Also, is the low water level deep enough to even keep a turbidimeter submerged if you had like an online station? So that's something you may not be able to do if you don't have enough water. Is the receiver accessible even? Is it too far from the construction site? Is it going to be physically possible and safe for you to do that? Is there a presence of any species at risk or protected species that are downstream of your site? Are you subject to any of those kind of approvals, permissions, regulatory requirements that are tied to those types of species? You might need more intensive, continuous monitoring on sites draining to species at risk habitat, and it's really usually determined by the regulatory body administering the legislation. You also want to consider the type and location of discharge points. So is it easy to get to the equipment to install and to download? And you have to look at safety considerations. Also cost considerations. So if you were to monitor pond effluent, if you chose that was the way you wanted to go, like I'm going to look at effluent from my sediment control ponds because a lot of my flows are going through ponds. That's just how my site is set up. How many ponds do you have? Is it going to be expensive? How are you going to set that up at all these different ponds? Or do you just have one pond and that's not too big of an investment? So a lot of considerations when you're putting together your monitoring approach, and it is very site specific for sure. Okay. I did see a few questions. So before I get into this kind of part of the presentation that's kind of just going through some like examples of problematic if things that happen on erosion and sediment on construction sites, ESC failures. I'd like to maybe answer the two questions I think that came in.
Yes. So the first is actually not technically a question, but if there are species at risk, inspections may need to be conducted daily during wildlife active seasons if it's required by MNRF or MECP. And so the second, are you going to be speaking about the fines and penalties that you know of that are being applied to situations where ESC plans have failed or have not been followed?
There is some more information. I'm not specifically speaking about fines and penalties in a specific way, like this is exactly the total max amount that can be levied for each violation under those different acts. I think I put that stuff in the ESC guide where it specifically tells you, like, I think the maximum penalties maybe that can be levied for different violations. And I don't necessarily have a lot of information that I have specifically, even though I've spoken to like our enforcement here and there. It would be local to where we are in terms of, I only have like one example in my mind where there was a really significant fine levied, and I don't even know, it was in the media. So if you want to look into this, but it was specifically related to like a solar farm and repeated instances of exceedances, like really poor erosion control. And they were fined heavily. And if you guys want, I can kind of find that example and send it out after. But the details are kind of escaping me right now, but that was one of the most recent. Oh, solar farm in Hamilton Township. Okay. So thank you. I think that was Gary. Gary, yes. Thanks for letting us know. Yeah, so that's in the media. That's one of the big stories I've heard. But other than that, a lot of things are, I mean, locally, there's stop work orders sometimes. And then, there can be penalties where it's more just like you have to rehabilitate this and it's expensive. But in terms of specific fines in our area, I could ask our enforcement officer if there's been something recently, but I don't think necessarily it's as common as it may have been. And I want to say like back when I think DFO maybe had more kind of enforcement and control over these things, where there was more oversight in maybe a few decades back, even where it was a little bit more serious, where there was like kind of that serious tone taken, at least in our jurisdiction, to those types of exceedances and fines levied. But it's just been, I think, progressively less over the past few decades. So at least where we are, but I would love to hear from anybody else's experiences, because I know we're all coming from different parts of the province. So, okay, maybe we'll revisit again when we have another question period. Is there anything else there, or can I continue?
I think we can move on to the next section.
Okay. Okay, good. Okay, the good, the bad, and the ugly. So I'm just going to show a bunch of examples here. Hopefully this will be a bit interactive and not so just much me just talking and taking up all the air. So it's just an example. There's a lot of things that went wrong. Oh, sorry, Gary. Can you read that out, Sarah? It's harder for me to see the.
So from an MECP perspective, if the ESC is required through a provincial officer's order, the SC is not created and or followed, MECP may pursue charges. Non-compliance with an order is an offense under the EPA.
Mm-hmm. Yeah, I think I think there's all these potential for offenses. I think I guess the message, the general message I have, it could be wrong, but I'm pretty sure this is what it's like in our jurisdiction, is that it just doesn't happen very much. Even though the mechanisms are possible, the enforcement is just not really happening. And so somebody could be fined for something, but isn't a lot of the times. And there's no enforcement, there's not enough enforcement officers, or there aren't regular inspections by enforcement that would identify those things. That's what I've noticed, but I can confirm with enforcement like how things are happening lately and whether that's changed. But in past conversations with them, that's kind of been the tone. So if anybody wants to chime in, I mean, you can type it in the chat and maybe Sarah could read it off, but I wanted to kind of show this as an example. This is a site where the site we worked on was supposed to be like a really good demonstration of a whole bunch of erosion and sediment control practices beyond just the basic sill fence and a pond. And so they were supposed to be like kind of a higher level standard above. And it's clear they did spend a lot of money trying to put in erosion and sediment controls, but then weren't always executed very well. And so this is an example, and particularly anybody who attended the last workshop where we talked about the proper installation of things like this. I'd love to hear if anybody has anything to kind of like comment about what exactly went wrong and why there's they've seeded this. Seed has come in a bit, and they've also used an rolled erosion control product, but they still have a gully there. Okay, I'll go ahead and maybe you guys will chime in on other ones. So always considering there's actually a lot of things wrong and not just the thing that's mentioned here. So it does seem to be the wrong orientation. So it should be installed down the slope and extend to the top of the slope. There should be an anchor trench at the top where it's keyed in there and at the bottom, and be in continuous contact with the soil surface. And there should be an overlap on those edges. But it also seems like this slope could have benefited from maybe a slope drain. It doesn't seem like the seed that was there was established enough to receive the flows that were going down the slope. And so there's a few things that could have been maybe improved. And the unfortunate thing is it's an investment has been made here and money has been spent, but at the end it's still like not working very well. So it's kind of wasted effort to some extent. So yeah, proper installation is really important in that case, I think. Another example of a rolled erosion control product installed for like a cutoff swale. In this case, like, well, what went wrong here? Again, it's the installation and orientation of the lengths to some extent. So the strip should be applied parallel to the direction of flow. And as you can see, it looks like almost like either this is torn or the seam was in the middle. But it should be anchored at the top of the slope on both sides and be in continuous contact with soil surface and overlap again. Could have maybe benefited from some more ditch checks or something to slow down flows if this is too much. But it does seem like there's rip and in the middle there, and so it could have just been the way the blanket was installed that wasn't ideal in terms of orientation. You also want to consider when you're installing that clods in the soil will create air pockets, which is where stormwater goes through the blanket and erodes the soil below, and that's exactly what you don't want. You don't want really good ground contact. You don't want these kind of unprepared soil where there's these clods and create a tenting effect. That's really bad for blankets. Here's kind of an example of unprepared soil and how it just won't work and water will be flowing underneath there. Also, on the left, you'll see there's tenting. It's not really properly prepped, the slope. It doesn't appear to be properly anchored to the slope with staples. And on the right, you'll see like really good ground contact, good soil prep, and ground contact is ideal there. And that's kind of what you want to be seeing when you're installing a product if you want it to work. If you spent all that money to purchase it, you want to make sure you take it all the way and install it properly as well. Here's an example. We talked a lot, I think, when I do the best management practices content, which I did last week on Thursday, I tend to talk a lot about slope drains. So here's another example. So why is the slope eroding? It does seem like they did try to install a slope drain. I had some people in some classes say, well, maybe it's not actually installed properly because of the way it looks, but assuming it is installed properly, why is it still eroding? Does anybody want to chime in? Provide the answers. I mean, in this case, it does seem like they've mulched the slope, but it doesn't seem like it was sufficient protection, stabilization, heavy precipitation directly on the surface. Yeah, that's right, Brett. Thank you. Can you read some of the other? Oh, the single drain maybe can't convey enough flow. I would say that's true too. It's unclear what's happening with the drain. It does seem like there's maybe some sort of berm ditch situation halfway, not halfway, but at the first quarter of the hill there that's supposed to be collecting flows. But water incident on there is clearly still causing that real erosion. And it doesn't seem like that mulch was enough to protect that surface based on the flows that they're getting. So I think there needed to be some better stabilization, or maybe the slope drain needed to be a little bit improved, or maybe they needed to install like another interrupter, flow interrupter, and then convey from that point too, so that you just don't have such a long slope. And that's where water kind of picks up speed and becomes highly erosive. And then you start to see the rills forming like almost towards the end of the slope there. Here's another situation where maybe a slope drain could have helped to mitigate this problem and this failure. So again, it looks like it's been mulched, and then you see that there's definitely a point where concentrated flows are just even just roughening up the surface. Yeah, roughening up the surface before you mulched it would make a difference too, and just create like more kind of slow. It slows the flow down a bit, creates a roughening. And here you see, yeah, a slope drain could have had a good maybe effect on this particular project where there was definitely concentrated flows flowing down there. And if they had just kind of contained it to that area and then directed it down a slope drain, then that would have been a stable thing to take down the hill, down the slope, instead of just flowing over your stabilized surface and just washing all that mulch away. Here's another example. Yes, there's a silt fence, sediment fence, but there are no posts, and you should always remember there should be no more than 2 meters apart. Structural fencing support like page wire or 10 by 10 wooden posts would make for a stronger sediment fence. So, I mean, that's a lot of water. It definitely needed to be stronger, but it doesn't even meet the minimum criteria where they're 2 meters apart. So, I mean, there's a lot of problems on this particular one, but there's an obvious one. And then always consider, like, if you do expect it to be potentially overcome, you can always bolster with options. There are options to make it stronger. With this sediment fence installation, I'm curious if anybody's aware of why it's not quite right. There, let me know if there's any answers. I can't always see them in time. No J hook. Yeah. Thank you, Amber. Doesn't stop the flow. Yeah.
Not terminated properly.
Yeah. Not
Doesn't
terminated.
stop the flow.
Yeah. You need a J hook. You always want to terminate. You want it to go up. The end runs of any perimeter control should extend the distance up upstream to prevent flow from going around. Not wide enough. J hook, likely not. Sorry, can you read them, Sarah? They disappear after a while for me.
So not wide enough. Could J hook, likely not the proper control.
Mm-hmm. Yeah. But whenever you don't J hook, it's easily for water to flank around the measure. So that's something to always keep in mind. It's the same thing with any ways to handle staking when bedrock close to or at surface. Can you read that out again? Sorry, it disappeared again.
Are there any ways to handle staking when bedrock is close to or at the surface?
So it's staking for a sediment control fence, I guess.
I believe so. Yeah, if you can't get the stakes into the ground.
Mm-hmm. That's challenging. So you would definitely, consider a perimeter control that doesn't have to be staked in as far. So there's silt socks, which people do like put a bit of a depression, and then they do get staked in, but maybe it doesn't require as much. You could consider the same things you would consider in frozen conditions. So some of the stuff we talked about in winter, but again, like the winter, like frozen ground installation of silt fence is not going to be as effective. So that winter installation would be that you put like a sediment silt sock on the upstream side instead of trenching it in to keep it in place, but you would still need to stake that in too. So you'd have to get like some sort of leverage in there, but anything that can't be any of the perimeter controls you're going to consider. So the other option in the winter one was just like a mulch berm But anything, you're going to have to consider something that creates a berm but doesn't like allow water to pass underneath, which is what's going to happen when you have something that's not trenched. So there are some perimeter controls considered, but like if it's not going to be trenched in, if it's not possible to like stake or trench it in very much, it's just going to have to be more regularly maintained. And then another way to look at that, well, it means I have to have multiple barriers or be more careful in that area because I can't make something as strong as it would otherwise be. That would be what I would think maybe. Okay. Moving on to outlet protection, just reinforcing the importance of stabilizing the flow path from where you are discharging water, because you can create a whole bunch of like sediment entrainment and create like a problem where you didn't otherwise have one. If you don't interrupt your flows, disperse them in some way, as you can see on the left, the flows are being interrupted at this outlet culvert. I just want to consider like how you can either prepare the ground surface, ideally prepare the ground surface to receive the flows that are expected, somehow slow down the flows, disperse them if you can, but anything you could do to reduce erosivity, you should be doing at outlets. Looking at Goldilocks edition, this is what I thought. When I saw this, I thought this is Goldilocks. So the stone's too large. In this case, when you're doing a stabilized construction entrance mud mat, you want to consider the right stone sizes. You want to avoid using large diameter rock that can become lodged in between the dual tires, and it can also become a liability issue. If it's too large, they may also want to avoid driving over it if it's too bumpy. And so you want to create some bounce. You don't want the stone to be too small, because smaller stone also means less void space, and therefore there's less space where sediment can be like fall out and fall into that area and be contained in that stabilized entrance. So if you have really small stone size, it's not going to give you that bump that you want and that bounce that kind of causes sediment to dislodge. Also, if you have irregular stone sizes, like some small ones and some large ones, it'll all just fill in. And again, very few voids will be there, so you don't want that. And you just want stone that's just the right size. And so that's something to consider when you're making these stable entrances. Here's an example of where it looks like, okay, well, is this rock disappearing? Really, this could indicate that it's just a stabilized entrance that's done its job and it's covered in sediment, or and just needs to be like some new stone needs to be placed there, or like it needs to be, maintained. Or it could mean that the rock is just being forced into the soil because you didn't underlay with geotextile fabric and it's being kind of just pushed down into the soil below and it's just disappearing. So I'm going to consider installing filter fabric under the rock as part of your mud mat stable entrances. Here's another pretty obviously terrible example of a dewatering bag. So in this case, where it's used, you want to make sure it's in an appropriate location and that it's changed when required. This one doesn't even look like the hose is really attached, but you always want to ensure it is properly secured and water is only leaving from the seams. If water is only leaving from the seams, it could be that the bag needs to be replaced because it should be leaving from the whole surface area. You want to ensure that underneath there's a stable path that can receive those flows without causing erosion. So well stabilized with vegetation or stone or something like that. And the path from the bag to the receiver is also going to be stable enough to support like whatever flows are going to be conveyed. You also want to monitor to ensure the discharge is clean and no erosion is occurring. And check on these regularly and replace as needed. And the bottom example is like a really good example. Multi-barrier approach, flat area, stabilized bottom, and overall a really good example of using a sediment dewatering bag. When you're looking at concrete washouts, you want to ensure that any sockut slurry, concrete acid washes, and other waste are not entering storm drains. It's caustic and corrosive, this type of material, and it means it can harm aquatic organisms. So you don't want this in your drains, which outlet to your ponds and ultimately to receiving streams and lakes. And so you want to make sure you provide somewhere for, if there's trucks that aren't self-washing, to be able to like wash out on site in a safe contained area. You also want to make sure it's identified on the ESC plan and the company is aware of the location and there's signage. And are the facilities adequate? Are they clearly identified? Is the washout material fully contained? And is it constructed with a vehicle tracking pad, like almost like a stable entrance to that containment area? So some things to consider, because it is something you don't want being released. Taking on bedrock fence can't be keyed in, so it can be an issue. Can you read that out, Sarah? That comment?
For staking on bedrock, the fence can't be keyed in, so it can be an issue with regards to water and sediment controls. But the best example that this person has seen is they had to use a fence for wildlife exclusion on Canadian Shield, and they ended up cutting the stake short and creating a tripod for support for the fence, and then glued the fence to the rock.
Oh, wow. I would love to see a picture of that. That's very like innovative.
Yeah,
I
sounds
like
very
that.
cool.
If there's any pictures, please send them to me. I would love to see that. Here's Rock Check Dam, and I would love to hear from anybody in class about why it's a bad example of a rock check dam. There's also, I mean, bad things about the picture overall, like it's not a stabilized swale, it's just bare soil. There's other problems here, but if you just specifically look at the rock check dam and how it should be kind of created and dimensions of it, and that's kind of the key to why it's not quite right. I'll give everybody time. Okay. Oh, no depression. In the middle for flow, yes. So if you look at, oh, my animation's not playing. Oh, animated, supposed to play. Okay, so this isn't working, but what's supposed to show in the picture? Oh, here it is. Yeah. So if you draw a horizontal line at the low point in the rock, that's supposed to intercept the edges. Otherwise, that's going to be a place where all your water is going to flow, because it always finds the low point and it's going to just erode the embankment, really. So you just want to consider that you're creating a depression and then extending that to the ends, and you should be able to see, if you draw a line to the low point, that it matches up with where the rock ends up at the sides of the embankment. Here, this is pretty clear, but what's wrong here? It's the lack of anything at all. That's what's wrong. It's even the fact that this much sediment has been mobilized to this point, and that whatever control would be here would have to actually handle this much sediment is already a problem. So there's an upstream problem for sure. But if you want to consider like what can you do, because you've already had the problem there, there's a lot of storm drain inlet protection options out there that are better than just a piece of geotextile fabric underneath the grate. I don't even think that one is there, so that's even worse. But definitely protect your storm drain inlets. Even if they're going to sediment control ponds are not like waste disposal, garbage dumps for all your sediment. You should mitigate sending sediment to those ponds as much as possible. They'll have to be cleaned frequently. If they're not cleaned, they're not going to work very well, and sediment's going to be discharged into the receiving water system. So minimize the amount of sediment that gets to your kind of final sediment detention facility controls by doing things like this at storm drain inlets, and of course upstream. But there's all kinds of different products on the market that can kind of capture more sediment and not need to be maintained, and not just fail as easily as these options that are commonly used. Okay, so I'm going to pause as the last. Okay, sorry, there's a question. Can you read that out, Sarah?
So you mentioned in the last presentation that rock check dams should not be installed in water courses. Could they be installed in ditches that are not considered water courses?
Yes. Yes, as long as they're officially not considered water courses, yes, I would say so.
Okay, great. Does anyone else have any questions? Feel free to raise your hand or put it in the chat.
So, okay, Brett,
Responding to the UV degradation, is there a general rule of thumb for replacement if left idle for too long? So, for example, a fence or silk, sock fabric, blanket netting, etc.
Is if it's left idle for too long?
Yes. So if it degrades with UV rays.
Like, should it be removed?
Is there a rule of thumb for replacement?
Okay. So I don't think, okay. Brett, can you use your mic and tell me what you mean? Sorry, can you elaborate? I'm a little confused. Hi, Brett.
Sure. Hello. Yeah, sure. Of course. Yeah, we've got a lot of construction sites that kind of, basically they put up the silt fence, for example, or perimeter controls, and then it just sits.
Yeah.
And then it sits and sits, and then you come back to inspect, and you start to see holes in the fence, and you start to see some of the twine. If they've got some straw bales, it's starting to fray, and it's like, at what point in time should they just replace these? Because they've just sat too long in the sun.
Yeah. If they're not needed, so if you don't need sediment control anymore, they should definitely be removed. And that's a thing that you see a lot where the construction site's largely complete and largely stabilized. They actually don't need the fence where it is anymore at all. A lot of times people put fence everywhere around their site, even if it's just not going to really receive flows, and put areas where it's not hardly needed, but they'll just leave it forever and ever and not remove it. And so very specifically, we say in the ESC guide, you should be removing your controls when they're not needed. You do not leave them there. It's not a garbage dump for you to always forever have this stuff. If it's like socks, I mean, some people will kind of, I think some of the netting the mesh is biodegradable and some of those things, but I don't know how quickly it'll always degrade. So if it has like compost or wood chips inside, they can be cut open. You can remove the material and spread it around. You can also seed some of them depending on the material. I don't think that would work for the wood chips as well, but like there used to be more of, you would see compost filled silt socks. You can seed those, leave them on site if you want to, or just spread that material out and use it. So that's something that's kind of got a bit more life after. But definitely either the sediment control is needed to protect the environment and you have to maintain it and it shouldn't have holes, and it should be maintained throughout the whole process until you achieve this level of stabilization that's specified in your agreements with the municipality. If not needed anymore, then out of there, like it shouldn't be in place anymore. Sarah, I think there was another question.
Yes. So what are the reasons why rock check dams cannot be installed in watercourses? I assume it would block fish passage, but are there any other reasons?
Shouldn't be putting material in watercourses at all. Definitely not blocking fish passage. If you have a permit to do in-water works, there's other materials you should be using to do like the dam and pump system. Cofferdams would be something, because then you actually would be creating your you would isolate your workspace. You would not be having something that's permeable. So there isn't any good reason for rock checks because they're designed to slow flow and allow sediment to settle out. And once you are in a receiving water system, you should not want sediment to be in there and sediment to be settling in there, because if you have a rock check, that means you have sediment in your water that you're trying to remove, and that's already in your water course. And that means you're leaving sediment on the stream bed, which is going to compromise all the aquatic system, ecosystem like functions that are associated with benthics and all kinds of different functions. So having a rock check there assumes you're trying to clean it from sediment, but also that you're leaving sediment in the stream. If you're doing in-water works, there's different ways, and you have to fully block water with a cofferdam, not with a permeable dam like a rock check dam. Sarah, do you have any more questions?
It looks like that's it for now.
Okay.
We can continue on.
Okay, thanks, Becky. And hopefully that was good. I had a break in here, but I don't really think I need it. And if we're okay, I'm going to go ahead to our last section and just try to keep us on time. So this is just the regulatory framework for erosion and sediment control. I'll try and make it not so dreary, because I know regulations and legislation is not always the funnest topic. When you think about environmental protection, you want to think about whose job is it, and the ultimate responsibility does lie with the owner of the site, and liability is shared with the project team. And erosion and sediment control monitoring is a critical responsibility. When you consider due diligence, when you exercise due diligence, it means that every reasonable effort was made, and you demonstrated that. You address problems that you could foresee and that were preventable. You address them in a timely manner to minimize environmental impacts, and you ensure that required actions have been carried out. And it's just that all reasonable steps were taken to prevent a spill from occurring. In legal language, there's something called a standard of care. So due diligence is a defense in any federal legislation, and what it means in legal terms is such a measure of prudence, activity, or assiduity as is properly to be expected from and ordinarily exercised by a reasonable and prudent person under the particular circumstances, not measured by an absolute standard, but depending on the relative facts of the special case, so up for interpretation. I'm going to go into some of the key federal legislation that governs, that has like an impact related to erosion sediment control and has relevance. The Fisheries Act, talk about fisheries protection and pollution prevention, the Species at Risk Act, and the Canadian Environmental Protection Act. So the Fisheries Act is administered by Fisheries and Oceans Canada. It legislates fish and habitat protection, and the most applicable provisions really are fisheries protection and pollution prevention. So it applies to all Canadian fisheries waters that provide fish habitat and support fish habitat opportunities at any life stage. It can include permanently wetted areas and intermittently wetted habitat features, so pretty extensive. In the Fisheries Act, the pollution prevention provision prohibits unauthorized release of what they call a deleterious substance into waters used by fish, including unintentional releases. A deleterious substance is defined as a substance that's added to water or water-containing material that degrades or alters water quality or is detrimental to fish, the fish habitat, and those that consume fish, so humans. And this would include, by this definition, this would include sediment from construction sites. Environment Canada is the lead for pollution prevention provisions for federal land or industries, but DFO takes the lead when the pollutant is suspended sediment and not chemical in nature. The act includes a duty to report applicable to the owner of the deleterious substance or the person who caused or contributed to the release. And inspectors are often the first to witness such an incident, so you want to make sure at the onset of a project that reporting duties and protocol are established as part of the ESC plan. The due diligence defense that can be used is that no person, in legal terms, is no person shall be convicted of an offense under this act, the Fisheries Act, if the person establishes that the person exercised all due diligence to prevent the commission of the offense, or reasonably and honestly believed in the existence of facts that, if true, would render the person's conduct innocent. So common construction-related impacts could include inputs of substances from construction that are deemed harmful, like sediment, realignment or intrusion into the channel, impacts to fluvial process or riparian corridors, infilling habitats, wetlands, and coastal marshes, dewatering aquifers, and channelizing piping or otherwise altering headwaters. So moving on to another key piece of federal legislation that has importance in this regard, the Species at Risk Act. This is the federal one. We also have a provincial one. So designed to meet one of Canada's key commitments under the International Convention on Biological Diversity. And really the goal is to protect endangered or threatened organisms and their habitats. As specifically states, no person shall destroy any part of the critical habitat of any listed endangered or threatened species, or any listed extirpated species if there is a recovery strategy that's been recommended for reintroducing that species into the wild in Canada. Also, the Canadian Environmental Protection Act is relevant here. The goal of the renewed Canadian Environmental Protection Act is to contribute to sustainable development through pollution prevention. It respects pollution prevention, protection of the environment and human health, and it protects the environment, human life and health from risks from toxic substances. The substance is considered toxic if it enters or may enter the environment under conditions that have an immediate or long-term harmful effect on the environment or its biological diversity. if it constitutes a danger to the environment on which life depends or constitutes a danger in Canada to human life or health. So pretty broad. When a toxic substance is released into the environment, this is from Section 95, the person responsible must report the release. They have to take measures to prevent the release and mitigate any danger to the environment or public safety. Moving on, we're going to look at a bunch of pieces of provincial legislation. A lot of them have relevance actually in this regard. So these are the ones administered by MECP. So the Ontario Water Resources Act, the Environmental Protection Act, the Endangered Species Act, and the Conservation Authorities Act. Administered by Municipal Affairs and Housing, that's the Municipal Act and Planning Act. And then there are agencies that enforce regulations and policies under some of these acts. There are local municipalities, upper and lower tier, depending on the area, and conservation authorities have a role also. When you're looking at the Water Resources Act, the act is designed to conserve, protect, and manage Ontario's water resources for efficient and sustainable use. So this act is focused on both groundwater and surface water throughout the province, and it prohibits the discharge of polluting materials that may impair water quality. In this case, may impair is the key word, as we need to show possibility rather than likelihood of impairment. A person who causes the discharge has to notify the minister, so another duty to notify in this one, and ensures cleanup and restoration to original condition. Interestingly, all stormwater management facilities, so stormwater management ponds, are classified as sewage works under the Act, and construction of these facilities has historically required an environmental compliance approval issued by MECP. So when you're building when you're in your construction project and you're building maybe it's a sediment control pond, but it's in the location of where you're going to have your ultimate pond, permanent pond, you need to obtain an environmental compliance approval, or historically you've had to go through the MECP to get that. Some of these things are changing. But we'll get into that. The environmental compliance approvals list the requirements that you need to adhere to as the owner of that facility, including things like inspection and maintenance. And as long as you own that stormwater management facility, those are your responsibilities. From the developer, that usually transfers as soon as the municipality assumes the pond, the ownership transfers to the municipality, and they're responsible for maintenance of that facility for the rest of its life. There's been some recent changes to the ECA framework for stormwater management facilities. It's worth touching on now because we're talking about the Ontario Water Resources Act. The Consolidated Linear Infrastructure Permissions Framework is replacing the ECA process we've had to date, and it applies to low-risk routine stormwater management projects. It doesn't have to be ponds. You see their infiltration chambers, so any stormwater management facility. And so municipalities that apply can be given a single blanket ECA, system-wide ECA for all swim works that happen in their municipality. And so the permissions would be associated with construction, modification, alteration of any swim facility. And those responsibilities, permissions are passed on to the municipality to provide to people that are building these facilities. The ministry is transferring these responsibilities to municipalities and providing them certain criteria and guidance to be adhered to as they, provide these permissions. One of them is related to design, so design criteria for sanitary sewers. I won't say the whole thing, but that's the document that's available that came out in April 2022. And there will be monitoring criteria guidance that is under development, but not yet publicly released. And that is forthcoming soon, I think this year, but it's in the works still. And that's something that's supposed to guide municipalities as they start to assume this responsibility. So moving on to the Environmental Protection Act, this is also relevant. It's a key legislation for environmental protection, and it grants the MECP broad powers to deal with discharges of contaminants. In this case, in this act, it's any solid, liquid, gas, odor, heat, sound, vibration, radiation, or combination of them, resulting directly or indirectly from human activities that causes or may cause an adverse effect. Very broad definition, but definitely could apply to sediment releases. It prohibits discharge of contaminants Contaminants result directly or indirectly from human activities, and it requires any spill of contaminants be reported and cleaned up in a timely fashion. So this is the spills actions, and remember, this is where spills are reported in Ontario. I think it's been around in the same number for a really long time, but the duty to notify and contacting the Spills Action Center are part of all these acts here, as you see. So, I mean, that's how you would report a spill and do that part of the act and adhere to that, which would be the notification part. In Ontario, as I mentioned, we also have our own Endangered Species Act. Even though we also have federal, the purpose of this act is to identify species at risk based on the best available scientific information we have. And that includes information obtained from community knowledge and Aboriginal traditional knowledge to protect species that are at risk and their habitats, to promote the recovery of species that are at risk, and basically to promote stewardship activities to assist in the protection and recovery of those species. Under the Act, a person cannot is prohibited from damaging or destroying the habitat of a species that's listed as an endangered or threatened species. Okay, so the next act we're going to discuss is the Conservation Authorities Act. So the Act authorized the formation of conservation authorities. We have 36 in Ontario. Under Section 28 of that Act, the development, interference with wetlands and alterations to shorelands and watercourses regulations were formed. Those correspond to Ontario regulations 42-06, and then all of them that are from between 146-06 and 182-06 are the ones that apply to different conservation authorities depending on which one. For Kawartha Conservation, I looked it up, and it's the last one, 182/06 is their regulation. Ours is 166/06, but they're all the same development, that development, interference with wetlands and alterations to shorelands and watercourses regulations. So the regulations allow conservation authorities to regulate development and other activities taking place within valley and stream corridors, wetlands, and associated areas of interference and the Lake Ontario waterfront. Areas subject to the Act and applicable regulations are listed there. So hazardous land, stream valley systems, shorelines, watercourses, wetlands. The Ontario Conservation Authorities Act Section 28 regulations prohibit, regulate, or require permission for interference and alteration to watercourses, wetlands, and shorelines, development if the control of flooding, erosion, dynamic beaches, pollution, or the conservation of land may be affected. In this case, up till now, pollution has been identified as any harmful substance or contaminant that can be generated by development, including sediment. And regulations do allow us to issue permits, and permits can be subject to conditions and can be canceled if those conditions are not met. You see there's an asterisk. So due to changes to Section 28 of the CA Act approved under Bill 23, so the More Homes Built Faster Act, the conservation of land and pollution prevention provisions are being removed. So pollution will be replaced by the term unstable soil or bedrock. We are currently waiting the enabling Section 28 regulation, but until that time, the individual Section 28 regulations of Ontario's 36 conservation authorities are still applicable. The conditions when we impose conditions, it can include things like dynamic phased ESC plans, inspections, maintenance, SISEC certification, construction timing windows, water quality objectives, etc. Those are some of the conditions that can be attached to a CA permit. Another important act, the Municipal Act, the main statute governing the creation, administration, and government of municipalities in Ontario. And each municipality is given powers and duties under this act and many other acts for the purpose of providing good government and with respect to those matters under their jurisdiction. The act assists communities in the regulation of various activities which may affect the local environment, like things like stormwater management, solid waste disposal, sewer use, land use. But a key aspect of the act is that it provides individual municipalities with the freedom to adopt bylaws, policies, and guidelines that suit the unique goals and needs of their local community. As you can see under section 142, which is the site alteration section, a municipality can prohibit or regulate the placing or dumping of fill, removal of topsoil, altering grades. They can require that a permit be obtained. They can impose conditions on a permit, and they can establish a site alteration bylaw, which many have. And site alteration bylaws, they can include permit conditions that can be applied. They can require you to submit ESC plans for your development, and they can also take financial securities. Work orders can require you to the work to be completed within a specified time frame, and it can also permit the municipality to do the work at the owner's expense. And so, yeah, when you look at financial securities, you're looking at money that they collect from the proponent to potentially undertake the works if the proponent is unable to or unwilling to do the remedial works or, proactive works to prevent a problem from occurring on their site. For Bill 23 impacts the Municipal Act. It does impact section 99.1. The minister can make regulations imposing limits and conditions on the powers of a local municipality and to prohibit and regulate demolition and conversion of residential rental properties under this section. So there is changes related to Bill 23 to the Municipal Act as well. And then looking at the Planning Act, this is an act that sets out ground rules for land use planning in Ontario. It describes how land uses may be controlled and who may control them. Under the Planning Act, municipalities can make local planning decisions that will determine the future of communities. They can prepare planning documents, they can prepare official plans, zoning bylaws, and they can ensure that the planning decisions and planning documents are consistent with the provincial policy statement and provincial plans. So under the Planning Act, site plan control is a planning tool that a municipality uses to evaluate certain site elements. Things like walkways, parking areas, landscaping, or exterior design on a certain piece of land. And then plan of subdivision approval is to be sought from the relevant municipality when you divide a piece of land into 2 or more parcels and offer 1 or more for sale. So these are the regulatory mechanisms that allow municipalities to impose conditions for approval that ensure that the land is suitable for its proposed new use, and that the proposal conforms to their official plan and zoning in the community, and the community is protected from developments that are going to impose an inappropriate strain or undue strain on the community that exists or the environment. For example, there can be ESC plan requirements. There can be criteria for conservation of natural resources, flood control, and the requirement that proponents enter into legal agreements with the municipality. So if there's a legal agreement for the proponent to provide a financial security letter of credit, that it kind of serves as an insurance policy in the event that the municipality has to draw upon those funds to carry out ESC or remediation work that the proponent is unwilling to or unable to fund, and they can draw upon that money as like a bit of an insurance policy. There is also some changes related to the Planning Act, actually a bunch of changes under Bill 23, the More Homes Built Faster Act. There's some notable changes, specifically developments of 10 or fewer residential units are no longer subject to site plan control. It's also limiting the scope of site plan control by removing the ability of municipalities to regulate architectural details. But the municipalities can still use site plan control to regulate landscape design if it does affect things like safety, health, protection of adjoining lands, accessibility, and most importantly, from an LID perspective or stormwater perspective, the sustainability. So it can still regulate elements on the site that have to do with sustainability. And they also, with Bill 23, removed some upper tier municipalities' planning responsibilities. And yeah, so there's a bunch of them. I won't list all the municipalities affected, but there are some changes there too. Okay, that's all the legislation stuff that I think is relevant. Hopefully I didn't bore everybody too much with talk about legal things. But again, any questions, I'm happy to answer. I know we're 8 minutes over time, but I'm here if anybody would like to, anyone still on the call has any questions or discussion topics they would like to bring forward. I'm happy to chat. And I'll just do a little promo for the Source to Stream conference in March, and I'll just leave that up on the screen. But I'm happy to take any questions if anybody has anything. Sarah, if you have anything, let me know.
No questions in the chat just yet, but also feel free to raise your hand. Oh, is there a document or website that outlines the Bill 23 changes regarding ESC?
Yeah, so I mean, you're going to think this is funny, but there's an Aird and Burles, I'm pretty sure that's the name of the law firm, webinar. It's free. There are lawyers providing really good insights. I read a lot of like kind of legal blog posts about Bill 23 because some of them, the other documents are very dense, and like if they're very much like the legal language, it's not very helpful to read. It doesn't really cover everything. So I would say that there's an Aird and Burles webinar that I thought was really good, and there are a lot of blog posts from law firms, environmental law professionals that do a really good job of summarizing kind of the impacts. But in terms of a specific document, Aird and Burles, I'll type it in the chat. Sorry. See if I can chat. I think I have this right. Aird. I think that's right. Yeah, it's a big law firm. I think our former mayor used to work there, David Miller. Yeah, and it was pretty good. They had different professionals on the Conservation Authorities Act and Planning Act, and different people speaking about different aspects. But it's a pretty, like a lot of changes are being imposed, and it just received royal assent, I think, in November. So I think there's still some lingering uncertainty about how it will all play out. So there's more kind of to be determined, but some of the changes were supposed to take immediate effect. So I think a lot of people are still confused, but some legal experts have tried to I think they've done some really good blog posts, and those are to me, the best places to get like the most simple and well kind of like parsed out information on all the changes.
Thanks, Lisa. That's great.
You're welcome.
Okay, and just another question. Any plans in the future for STEP to produce drone ESC inspection and monitoring guidance resources?
No, we don't have that planned, but if that's something you think we should like look into, we should do that. I think we'd have to like start talking to first like some maybe some consultants that are mostly involved in inspections and see like the latest what they're doing and kind of build from there. But we don't have any immediate plans to do anything right now on that front.
Okay, great. So I think that brings us to the end of the questions today. If anyone has any questions that are still lingering, feel free to send Lisa or myself an email, and we can try to point you in the right direction. Thank you, Lisa, for your presentation today, for sharing all of this wonderful information, and for everyone who joined us as well. For a complete listing of all available training, please visit the Events and Training tab at sustainabletechnologies.ca. And thank you again. Have a great day, everyone.